And we are moving on to series and sequences.
All right, so a sequence is an ordered set of numbers. So you're going to get a bunch of numbers, and you have to figure out the connection. We have two types.
Patterns? What?
Yes.
Mathematics?
Arithmetic.
Arithmetic and geometric. So arithmetic is when you're adding or subtracting to get the next term.
Mm-hmm.
This is a formula. The formulas look scary. I get you because it's all sort of mathematical subscripts in this, but they're really not that hard, okay?
No.
A sub 1, you need to remember, it always means the first term.
If you click, I think it comes.
Oh, here it comes.
There you go.
Boom.
Oh,
Okay.
and
First term. N is just your variable, and it's the distance between the terms for D. Okay?
Now, the next part, to find its arithmetic, so this is just like how do you figure out what your D value is? You subtract the second term from the first term, you subtract the third term from the second term. If it's the same, it's an arithmetic, and that's your D value.
Mm-hmm.
Geometric.
We're going to do some examples, but we're just getting the
chart down.
Yes. So geometric is when you're multiplying or dividing to get to the next term. So you're going to have, again, the first term multiplied by some rate, and then the n minus 1.
Yep.
Okay, n is just the number term. So let's say we had like 2, 4, 6, 8, 10. 2 would be the first term. 4 would be the second term. That's what that n value stands for.
And the second part of that chart is just how to find its geometric. You actually divide the second by the first, and you divide the third by the second, and that will give you your R value if they're the same.
Excellent.
This chapter, you're actually given the most on your reference sheet.
Yeah.
So this is your reference sheet cropped out. So you get 3 of the formulas. You actually need to know 4, so you'll just have to memorize 1 in this chapter.
But we're not there yet, so don't worry about that. Okay.
Right.
So state if this arithmetic or geometric series, so is it, which one, and, sequence, not series, and establish what the change is. So again, we need to figure out, is this increasing or decreasing by a difference or by a ratio?
So if you click, Miss Dozier, I subtract the second from the first. I subtract the third from the second. And you can see they come up with the same exact value. So that means it's going down by negative 1.3.
That means it would be an arithmetic sequence, and therefore we could easily figure out, any of the other ones. Now they say establish what the change is. That's that D value. It's the distance between the terms. Some people think of it as a difference, but that's what that is.
Yep. So we're going to come up with the formula. So really it's just now at this point plugging and chugging since we know all our values.
There you go.
We like to simplify, so I distribute that negative 1.3 by multiplying.
Yep. Be careful with this. It looks different because you guys are used to it being on this side of the parentheses. You have to distribute that. That's one of the biggest mistakes people will make this chapter.
And then you simplify by adding your negative 9.4 and 1.3, and then that's your formula to get your sequence. So if you plug in 1, you'll get negative 9.4. If you plug in 2, you'll get negative 10.7, so on and so forth.
Now, we like it this way. This is technically not wrong.
Right.
We like it this way.
You should always simplify.
Always.
All right, this one. Now, looking at it, can you tell whether it's arithmetic or geometric? I know it's going down because it keeps getting larger and larger negative.
That 3 to 12 and that 12 to 48 is really making me feel like it's going to be geometric because that's a big jump. But let's check.
So I'm checking arithmetic first, so I subtract the third or the second from the first and the third from the, and they are not the same, so it's not arithmetic.
So to see if it's geometric, you divide. So you're going to take the second divided by the first, the third divided by the second, the fourth divided. You don't have to do all of them, but you want to check enough that you're confident that you're correct.
So divide them, I get 4. So, it's being multiplied by 4. So we know it's geometric.
So that 4 would be called the rate. That's the rate. So the change for a geometric series is called the rate. So the a sub 1 is the first term. So that's just whatever number's first in your list, in your sequence. And then you have your rate, plug it in.
Do not multiply your r times your a sub 1. Just leave it like that.
These cannot be multiplied. We should know that from our exponent chapter.
Yep, and that's your formula.
That's your formula.
Okay? Ooh, fractions.
Guys, you have a calculator, and you can use your brain.
Yep. So this is where the subtraction comes into play, and the multiplication and division is nice to do. So you subtract the second from the first, and you subtract the third. Oh,
there it is.
Skipped a step. Third minus the second, and I get negative 2/3. So it's going down by negative 2/3.
Yeah. And some people are like, you want to triple check because it's fractions, go ahead, grab negative 94/15, subtract negative 28/5. You're going to get the same thing. So a sub 1 is that first term, and then we have our difference, or our distance between values.
So then you plug it in, you distribute the negative 2/3 by multiplying, and then you combine the negative 44/15 plus 2/3, and you get the negative 34/15. So kind of ugly, but...
Yep. So again, this is just plugging in, distribute to go to here, and then combine your two leg terms to go to here.
And that's your formula.
Look at that.
Ugh.
Okay, again, I'm going to check. I'm going to subtract. So I subtract and
Nope.
not seeing it. Okay, so then I'm going to divide and, oh, hey, there it is. Great. Okay. So again, subtracting second term, first term, third term, second term, then dividing and seeing which one it is. So this is geometric because I can divide.
And then we have the first term is -4/3. The r is the -4/5 that we found. And then we just plug it into the formula and stop there.
Stop it.
And that's the geometric formula for that sequence.
There we go. All
Okay.
right. Recursive formula. Well, yeah, we got to start talking about vocabulary, people.
Yep. There's two ways to write formulas: explicit and recursive. We just did 4 examples of explicit. Now we're going on to recursive.
Yep. So with recursive, you're given the first term. You say, hey, this is the first term, and then your formula is based off of that number. So whereas the other one was explicit, you can just plug any number in and get it. With the recursive, you have to know that first term.
Okay, so we're going to use all the same sequences again just so you can see the difference between explicit and the recursive. So this one, you just have to identify your first term. So there you go.
Check.
And now you need notation.
Okay. You all need to not get over, but realize this fact right now. I know that this looks scary. We get that. This is just the term before. That's all this means. Whenever you see a sub n minus 1, that means the term before. Because if a sub 1 is the first term, every term minus 1 is the term before that.
So how do we get, in this sequence, we knew
I
that
hit
it
a
was
button,
arithmetic, and we knew that the distance was a -1.3, if you remember that back from when we did the explicit. So that right there is the recursive formula.
So to get a sub 2, for instance, if we put 2 in here, 2 minus 1 is a sub 1 minus 1.3, hey, that's -10.7.
And that's just how you come up with the sequence.
So geometric, okay, again, we need to identify that first term.
This one was being multiplied by 4,
Yep.
so your term would just be a sub n minus 1 times 4. So you need those two pieces in order to make the recursive formula.
So you need the term before n times 4. Look at us go.
Okay, this was arithmetic, but I can't really remember what the number was.
Oh, it was a big one.
Oh, distance was
There we go.
-2/3.
Perfect.
So again, a sub n minus 1 minus 2/3. That's how you get to the next term.
Now they do get trickier than this, just to point out, but we're just showing you the difference between the two right now.
Okay, so first term, the r was -4/5 in this equation, so it would just be a sub n minus 1 times -4/5, and that's how you get to the next term.
And look at us go.
Okay?
Now you might be thinking like, okay, well, when would I use explicit versus recursive? You might use recursive when it's like being added and multiplied, because then you say, okay, the first term, and then multiply by 2 and add 3. Okay.
All right, so this is just how we work a sequence. So an explicit sequence is defined by a sub n 2n minus 1. Find the first 3 terms. So n stands for your term number. So if we want the first term, you're plugging in 1.
Whoa.
If you want the
Slow
second
it down.
term, you're plugging in 2 to n.
Oh, yeah.
So the first term is 3, the second term is 5, the third term is 7.
It's that easy.
And identify a sub 1 is 3, a sub 2.
Yep. Now realize these are subs, and this is a variable, so you got to be careful. If the n was down as a subscript, that means something different.
Okay, so what term has a value of 53? So what number pops out of 53? Well, that's where you're going to sub it in for a sub n.
Boom.
Solve it.
Boom.
So the 27th term will give you 53.
Look at that. Explain why there will not be a term that has a value of 70.
Ooh.
Well, I would first try to see what term would have a value of 70. So I'm going to set it equal to 70. I'm going to add 1, and I'm going to divide by 2. Now, usually we tell you fractions are a thing, get over it, okay? But as far as counting, like when you have a term, we don't have half terms.
Right.
We have whole terms. We use whole numbers.
So it won't work.
No, it will not. Bam.
It's not a positive integer. Oh, there's a lot of stuff going on here.
Sequence is defined by the recursive formula
Oh,
given,
boy.
and they tell us that the first term is -2. Generate the first 5 terms of the sequence, label each term with proper function notation. So you guessed it, it's just a whole lot of functions.
Yep. So when we were going over the example, we used a sub n minus 1. They were using f of n minus 1. You just need to know that n minus 1 is that term before it.
Term before.
So we have our first term, which is -2. So then if I want to get to the next term, all I'm doing is adding 5 to every term. So here's all the notation, how it would work. You would plug it in. -2 plus 5 is 3.
So again, this means the term before. So now that we have 3, 3 is the term before, plus 5 is 8. 8 is the term before, plus 5 is 13. 13 is the term before, plus 5 is 18.
So there are your first 5 terms.
And
so
this is the function notation.
Yep. So it looks scarier, but really you're just adding 5 to every term.
Yeah, that's about it.
Okay, so we want f of 20. So sometime, if you know that you're going up by 5, okay?
Yep.
Term before, 19 times 5 would be 95. And then you would add the first term, so you get 93.
Yep. Look at that.
Or
so
you could
by
sit
5,
there and keep
20
adding.
times would be the 19 times the 5 because you're going up 19 more times. And then the negative 2 plus that. Bam. Hey, that's it, everybody. Have a wonderful day. We will see you in class.